Okay, so this is week 2 of the essential exam techniques for A-level physics course. Okay, and the reason that I'm doing this is because this is the single thing that is going to make the biggest difference to your grade. Okay, and those of you that are in year 12 and have only just started year 12, because we're still in September as this is being recorded, you haven't yet figured out that exam techniques is going to be your bugbear. Most of the year 13s are aware that they actually understand the physics. The physics isn't the problem. The problem is the exam techniques, and it gets in the way of understanding what's going on, and how to get full marks. Okay, so what we're going to do is we are going to do today command word scaffolds. Now, what does that mean? Okay, so there are lots and lots and lots of command words. Things like calculate, that's the most common one. So calculate, but then there are derivations on calculate. So there's determine, and there's show that, and there's deduce. Okay, so all of which include some calculations. But then in addition to the calculate versions of a command word, there are other command words, things like give and state. Those ones are simple, or more complicated ones, things like explain and describe and compare and assess and discuss and justify and I mean, there are lots and lots and lots of them. Most of them don't come up all that often. Okay, so the first thing I want to do then is I'm going to share my screen, and this is week 2 of the Essential Exam Techniques 8-week course, and so this is the second session, the second day in that course. And on the right hand side, can you see are a load of things that you can download, files. Okay, and what I'm going to do is I'm going to download the command word frequency PNG. It's the only one that's just a picture, and I'm going to click on that, and can you see it's downloaded in my top right hand corner, and I'm going to open it. Okay, and when I open that file, this is what I get. So now this is just anecdotal. Okay, can everybody see that? Could you please put into the chat if you can see that or not? Okay, Path can see it. Can anyone else see it? Yes, yes, yes. Okay, so you can see it. Good. Right, so this picture it's very anecdotal. It's one paper for Edexcel, one paper for AQA, and one paper for OCRA. It's not even a whole year's worth of papers. It's one paper each of them. But all I did was I went through and I did a tally chart of which command words come up most often. Okay, and you can see that I just tallied up. Now, I haven't even weighted them. So state is nearly always just 1 mark, whereas explain is nearly always at least 2 and probably 3 marks. Calculate can be 2, it's often 2, sometimes 1, but often 2, and sometimes as many as 5 marks. Okay, there were a significant number of 5-mark calculation questions in this year's full A-level exams. Not seen that before this year, so that's quite interesting. So this is very anecdotal, but you can see, I hope, that if you right, well, why can't I see myself? Right, if you look at the calculate, the determine, and the show that, which are really all of them calculate questions. Okay, if you look at the, if you add those ones up together, can you see that the calculate column would be off the top of the screen? Okay, it's by far the most common thing that you have to do. But the next one down is explain. Okay, so explain is the single most common command word other than calculation type questions. Now, you would expect in A-level physics for calculation type questions to be right up there. You would. And calculate questions, obviously, or derivation type questions come up a lot in maths as well. And all of you are like really familiar with maths too, because nearly everybody is doing A-level maths as well. And those of you that are not doing A-level maths have only just finished doing their GCSE maths. So you're really familiar with maths. Now, in maths, you very rarely explain, very occasionally. But this explain, just this one command word is the reason why most people find A-level physics really difficult. Explain is the biggest culprit for that. The second biggest culprit is describe. Okay, and you can see that all of these others derive and draw and suggest and complete and deduce and identify and sketch and estimate and name and compare and label and define and discuss and assess and criticize and justify. All of those, some of which are not even on this thing, those ones are also RANs in terms of how many marks are going to be allocated to each of those command words, probably in your final exam. So the ones we absolutely have to get down is explain and describe. Those are the two. Obviously calculate, but actually nearly always the calculate questions most people are all right with. There's a bit of figuring out how to solve problems that's an issue for quite a significant number of people, and that will be another lesson in this course. Okay, so but today what we're going to do is we're going to focus in on the most common command words that's not calculate. Sorry guys. Because everybody without exception hates these wordy questions. Even if you're good at them, most people hate them. It requires too much bandwidth when you're thinking about it. And lots, and please don't let this be you, lots and lots of students, they don't ever do them. They do the calculates and they kind of they're blind to the fact that they're leaving the wordy questions. And then they're surprised when they don't get a good result. So yeah, not great. Okay. Okay, so we're going to start then with explain. Okay, right, I'm just rearranging myself. Right, I am going to clear my drawings and I'm going to close this picture. And we're back at the course platform, okay? And what we're going to do is we are going to look at the command word. I'm going to go through command word techniques without the annotation. So this one, can you see? I hope you can see it's the fourth item down on the list. So I'm downloading that one and now I'm going to open it. And here it is. This is the command word techniques document. And there they all are: deduce, discuss, compare, assess, determine, etc., etc., etc. And actually explain in this list is 8th on the list. I can't remember why they're in that order. I think I might have, they're not even alphabetical, are they? It's rubbish. But anyway, they are all there. I'm going to go to explain right now. If you want to cheat or speed things up a bit, you can do Control F. I hope you know that you can do Control F on any PDF or Word document that's on Google Drive or anywhere else actually, and you can find the command word that you want, right? So you can see that explain comes up 7 times in this document. So if I just do a down arrow, there it is, there's explain. Okay, right, so the meaning of explain. Right, so in Edexcel, so if you're an Edexcel student, an explanation requires a justification, exemplification of a point. Okay, a justification or exemplification. Exemplification means example. Okay, the answer must contain some element of reasoning or justification. Again, right? This can include mathematical explanations. In other words, you can use equations in explain answers. Okay, right. Then it says AQA is give reasons. That's what it says in the spec. Okay, That's not actually what appears in the mark scheme. And then the International Baccalaureate says give a detailed account including reasons or causes. Okay, so that's really not very helpful, is it? Whoops. So what we're going to do then is we are going to structure, give ourselves a scaffolding for an explain question, okay, or rather an, well, right, okay, you'd think, wouldn't you, Saphira, that OCR would tell people what they really mean by explain, and the reason it's not here is because they don't. So we're just going to go with the other ones. I promise you that this applies to OCR as well, okay? I promise you that it does. Anyway, right, okay, so explain. Explain. It was a really good question, by the way. Explain. Okay, so explain then. Okay, those of you who are my students that have had me yak at them, or maybe even in a free demo that I've done with you, I have talked about explain. I've put it in my my social media postings what explain means. Can anybody tell me there are two things that have to go in an explain answer? Does anybody know either of them? Fact. Consequence. Yes, we got them straight away. Yes, Sophia, point and consequence. Okay, I like to call it a key fact because it's not just any old fact, it's a key fact, and that's the very first bit of the explain, and the second bit of an explain is the consequence. Right, now, the key fact has to be the right fact, okay? So if we're trying to explain, for example, why the sky is blue, the fact that my front door is white doesn't help. It's not a key fact. It's a fact, but it's not a key fact, okay? So it's not just any old fact. It's got to be the right one. Right, now, when I'm teaching about this in free demos and stuff, and I've even put this on social media, I've talked about a cat called Derek, okay, and I've said, okay, that your mum says, explain to me why your bedroom carpet's wet. Okay, so this is an explain answer, and I use it to illustrate this key fact consequence structure. So you have to go, right, well, I've got to come up with an explanation, and I'm explaining why my bedroom carpet's wet. So really, my key fact, my starting point for my explanation has to come from where the water comes from in this explanation anyway. So we've got then the source of the water is our key fact. Okay, so you say, well, Mum, I had a glass of water on my bedside table. Okay, that's your key fact. And that is relevant because that's the source of the water. Or at least it might be relevant if it really is the source of the water. But if the source of the water wasn't that you had a glass of water on your bedside table, but there's a hole in the roof, can you see that that hole in the roof needs to be your key fact? Can you see the key fact depends, that the whole explanation hangs on your key fact, right? It's got to be the right one. Okay, let's imagine that we don't have a hole in the roof and that it didn't rain, but that we've got a glass of water on the bedside table. So you say, well, Mum, I had a glass of water on the bedside table and Derek, the cat, got into my bedroom. So can you see now I've got two key facts. Not only have I got a glass of water, but I've got a cat called Derek. Okay, and they're both of them relevant because guess what? Cat Derek does what cat Derek do, which is to knock off the glass of water. And the consequence is the water went all over the carpet and now the bedroom carpet's wet. Right, now, can you see the structure? Now, it happens to be a 3-mark explain. I've got two key facts. One is my glass of water on the bedside table. The next one is cat Derek got into my bedroom. And the consequence is that cat Derek knocked the glass of water off and the bedroom carpet's wet. You can see how the structure goes, right? Now, in A-level physics, each key fact scores you 1. And in A-level physics, each consequence scores you 1. Okay, now sometimes there's 2 key facts and 2 consequences, but it's a maximum of 3 marks. So it doesn't matter which 3 of the 4 you give them, maybe. Okay, that's sometimes what happens on mark schemes. But nearly always, not always, but nearly always, explain answers are at least 2 marks. And one mark is for the key fact and the other mark is for the consequence. So you've got to practice using the right key fact and the right consequence. Right, now, the example that I've got here is about the photoelectric effect, and I doubt very much whether any of you in year 12 have done the photoelectric effect. So what I'm going to do, there are 7 explains here. Yeah, I think, yeah, okay. We're back to the beginning. So I'm not going to use this for my explain answer. So I'm going to go back to my course platform and I'm going to go to the spreadsheet at the top there, which is command words. And I'm going to click on that one. Okay. And then I'm going to open it. And it's opening LibreOffice because I haven't got Excel. Okay. Ugh. And apparently the recovery failed on that document. Okay, so now you can see what's on this command words spreadsheet. I'm going to make it, let's make it smaller, just so that it's more in the middle. Okay, and I'm gonna move it just to the right so that you can still see the explain key fact consequence thing. Okay, so you can see, I hope, that we've got AQA papers, Edexcel papers, OCR papers. Okay, and if I move that up, oops, come on, let's move that up. I hope you can also see at the bottom I've got 2017, 2020 and 2023. Right, now 2017, these are all paper ones. Okay, so they're full A-level paper ones. So so year 12, be aware that there's going to be a lot of questions here that you can't answer. Okay, in the 2020, these are all paper 2s. And in the 2023, these are all paper 3s. Now, pretty much everybody is going to struggle with some of these because these are proper year 13 papers. But can you see we've got in this column, column D, okay, I've got explain, describe, there's draw, label and show. And then the Edexcel is explain again, deduce, state, calculate, derive, and then state, determine, suggest, define, describe. All describe and explain. That's 2 things together. Okay, so let's just go and have a little look and see whether or not question 1.2 explain is a suitable question. So I'm going to do control and click. 1.2, which fundamental, we've got to explain which fundamental interaction is responsible for decay. Right, now, some of you won't have done this yet. This is, in fact, some of the year 13s won't have done this yet because particle physics is taught in year 12 for AQA, but in year 13 for OCRA and Edexcel. So we can't even use that example of an explain question. Okay, so what I'm going to do is I am going to go to clear my drawings. I'm going to go to my documents, and I'm going to pull up some questions by topic, and I'm going to go to I'm going to start with mechanics. Right, you do quite a lot of mechanics at GCSE. Oh, as an explain format, would that not be a bad question? As how do you explain a decay is carried out by a W boson? Okay, path. It's got to do okay, it's got to do with how do you decide that it's a weak interaction? Ooh, okay, yeah. So it's got to do with the conservation rules and what interactions are felt by which particles and how you can figure out that it's yeah. Okay, right. So what we're going to do is we're going to do. Oh, should we do motion in a straight line? I think we could do motion in a straight line, we could do momentum. Most of you are all right with moments as well. Oh, moments, momentum, or motion. So momentum. Right, I've got a vote for momentum. Anyone else want a vote for momentum? Oh, we got moments, moments. Oh, moments, not moments, please. Oh, lovely. Projectiles. Okay, we're right. Projectiles is beyond the Ed12, so we could do motion in a straight line. But look, I've got too many. I've got too many votes for moments. I'm sorry, Adam. Okay, so we're going to pick moments. Okay. Did that work? Why is that not working? What happened there? Why is that not opening? Oh, it did open. What? Why? Strange. Very strange. Okay, so this is moments. This is moments, right? Let's find a relatively straightforward moments question. And let's see if we can do an explain. Okay, so obviously we're not going to, oh, that's not straightforward. No, I'm not going to do that one. I'll tell you what, let's do a control F and let's put explain. And look, there's 10 occasions. State and explain the horizontal, no, that's a magnetic field. Explain what a student could do to find K. Oh, no, magnetic fields, right, that's too much. State and explain, or explain why. There we go, we're going to use this one. Even that's too hard. I'm gonna. Right, okay, let's do this one. I know it seems really weird because I've picked something with a seismometer in it, and seismometer won't even appear in the specification. The reason I've picked it is because, right, well, first of all, it looks really complicated, and it's not. And second of all, because it's a relatively straightforward explain. Okay, we're not going to answer all of this question, but what I want to do is I want to use it as an example of how to do an explain. Okay, so right now, this is a seismometer. Does anybody know what a seismometer does? Measures earthquakes, absolutely, well done. Okay, so right now what we've got here then is we've got it's a paper trace. So this drum, can you see, it's a rotating drum, it's going round and round and round and round and round and round, and it's leaving a trace, and this ball is pressing against it. There's a pen and it's pressing against it and it's leaving a trace, right? And when the ground shakes, the ball kind of stays where it is and the ground moves past it. And so the ball goes up and down and there's a spring holding it in place and the whole thing leaves like a wiggly line behind, right? So this is, and can you see it's bolted really strongly to the ground and there's a big strong frame and this is pivoted here and so the ball is free to move. It goes woo, 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 and it draws a wibbly line, okay? All right, now that's a seismometer, okay? So it measures earthquakes, that's what it does. Okay, and it asks all sorts of questions. Look, the ball is made of this, and show that the weight of the ball is this, and calculate the moment, da-di-da-di-da-di-da. Okay, we could calculate the moment. But what we're going to do is we are going to keep on going, right? Is calculate the extension of the spring, and then it says, before the earthquake occurs, the line being drawn on the paper is horizontal. Okay, so the ball isn't moving and the drum is rotating and it's drawing a horizontal line. So if you unraveled the paper off the drum, it would look like a horizontal line. Right, now it says, explain what happens to the line on the graph paper when an earthquake is detected and the frame of the seismometer accelerates rapidly downwards. Okay, so right now, remember what we've got. We've got a frame. We've got a big fat ball with a pointy thing. We've got a spring holding it up, right? The pointy thing is drawing a line on this drum. right? And the drum is rotating. Oh, yeah, it's being held, right? And this thing is it's really rigidly held down, but there's a pivot there. So if I do a pink blob, that's a pivot, and all of this pink bit can move up or down, right? It's free to move. It's held in place by spring, but a spring won't stop it from wibbling about, will it? Okay. So what we've got to do is we've got to explain what happens to the line on the drum. Okay, explain what happens to the line on the graph paper. Okay, now it says that the frame rapidly accelerates downwards. So all of this, all the orange stuff goes bang down. I want you to imagine now what's going to happen to the line that the pen is going to draw. What will happen to there's a pen, my blue arrow is a pen. Everything orange accelerates down, bam. What's going to happen to the line it draws on the paper on that drum?
It's going to go up.
Yes, it's going to go up. Right now, we've got to explain that. How do we explain that the line goes up? Now remember the structure of an explain answer. Explain is key fact, consequence. Okay, so what is our key fact? In other words, why does the line go up?
Because the drum moves down.
Can
Because of force.
Yeah, okay, the drum moves down, not just the drum, but all the whole frame and everything moves down. Okay, but why is the pink bit not going to move down, the pink and blue bit? Can you
Because
see?
the spring compresses.
Yeah, but
Isn't
why?
that like because a force is being applied to it, so work is done on it?
Hang on a minute. Hang on a minute. Where's the force?
Well, the entire system is accelerating downwards, so as such, it has a
Yeah, it's
mass.
not the entire system though, is it? It
Okay, but
leaves something behind.
the orange
The
bit,
orange goes down because it's fixed to the ground and the ground literally has moved down.
yeah. So the ground exerts a force on
On the
on
frame and the
the frame.
drum and but what happens to the pink and blue bit? So everything orange in that picture moves down, accelerates down. So the pink part is held in place due to moments, is it? The pink part flicks up, does it? I don't think the pink part does. The trace will apparently go up, but it's not really that the pen has moved up. It's that the paper has moved down, hasn't it? So this has got to do with momentum, remember? Oh, did we go with moments? I can't remember. Anyway, this is actually to do with momentum. Does the pink part stay in place because of the spring? No, it's not got to do with the spring. It's got to do with the fact that it's got mass. Okay, so the pink blob, the big pink ball, okay, that's got significant mass. The orange bit moves down, but the pink bit, because it's not rigidly held to the orange, and because it's not bolted to the floor the way the orange bit is, the pink bit doesn't move. Not initially. So everything orange moves down, bam, and effectively the pink and blue bit just stays where it is. I mean, this hinge end will move down, but the pink bit won't. won't, I mean, it's gonna lever. It will, this bit, basically this bit stays where it is and everything else moves down. So if I was to draw a picture of what happens when the frame of the seismometer accelerates rapidly downwards, what will happen is if I draw it, let me draw it in white. Okay, everything that's orange has moved down. Okay, okay, and that bit, that pink hinge has moved down. But can you see the blue bit stays where it is? And in fact, actually, whoever said the thing will flick up, it really would actually. So I stand corrected, Path, because you said that the needle will flick up, and it will, because it's pivoted, and the pink pivot bit will move down, which flicks up the bit the other side. But can you see the blue ball, the big pink or blue ball, that is basically going to stay where it is, because it's not being pulled down by the fact that it's attached to all the rest of it. There's no, that, can you see? Now it will eventually fall down, okay, and then it will bounce because of the spring, right? But can you see, they want to know what happens to the line on the graph paper when the frame accelerates rapidly downwards. And when it accelerates rapidly downwards, it's going to draw a line that goes up. Okay, and it's because basically the drum has been dropped past the pen. Not that the pen's moved up, but that the drum has moved down. Okay, right, now we've got to explain this. Okay, what's our key fact? What's the important thing here? Right, okay, so it's not linked, well, it sort of is linked to momentum. Okay, in order for an object to change its momentum, it has to feel an unbalanced force, doesn't it? Yeah, okay. So we've got the force is the change in momentum divided by the time. Right, now those of you who are in year 12, you will know this equation like this. Okay, A is the acceleration. Okay, so A, and you know this equation as well in year 12, V minus U over T. It's the rate of change of velocity. So it's your change in velocity divided by time. If you put that in there, you get F is equal to M V minus U over T, which then becomes, well, it becomes F is equal to MV minus MU over T, and that top bit is your change in momentum over time, okay, which is this one. So this one is basically a statement of Newton's second law, which is F equals ma, okay, and what it says is that unless there's a force acting on something, it doesn't move. Right, now, because of the hinge, and because it can, the blue ball doesn't move immediately. The rest of it has to go down because it's all rigidly attached. But the blue ball basically stays where it is. It's like, it's this tendency for things to stay where you put them. I mean, it's called inertia, but really it's mass. It's measured in kilograms. Okay, the more massive something is, the more difficult it is to accelerate, and the more difficult it is to stop moving as well. So the ball is going to stay where it is because it doesn't actually have to move because it's not rigidly attached. It's all floppy. Okay, which means that it stays where it is. Okay, and it ends up staying where it is, and the ball, the drum moves past it. So, but we've got to explain this. So we've got to hammer our key fact and our consequence, right? So what we're going to do is, what's our key fact? The key fact is that the frame and the paper drum all move down. But the pen and ball arrangement, the massive ball, okay, and the pen, because that's attached to it, stay where it is initially. Okay, so the drums move down past it. Can you see that? Right, now, after that, what's going to happen? So after that, then the ball will start to fall. And it's going to go past the equilibrium position and it's going to end up bouncing on that spring, isn't it? And so you can imagine, can't you, that what will happen on the paper trace is it's drawing a horizontal line, and then what will happen is it will go, actually I should start from the other end, shouldn't I? Oops. Should start from the other end. It will draw a horizontal line, and then the drum will move up past it. So effectively, this will go woo, and then the ball will drop, and it will start doing wiggles like that. Okay, and that is what the seismometer trace looks like, and it's because the ball is bouncing then on the spring. Okay, so now can you see that we've got, this is my key fact. The frame and the paper move down, but the ball stays stationary. That is the first key fact. Okay, so what's the consequence? What is the effect of this? Yes, exactly right, Safira. The line gets drawn upwards. Can you see that's the consequence? So a line is drawn upwards on the paper. It goes up, yeah? Right, now, this was question 14, part D, and all I was trying to do was get you to start thinking about how to structure an explain answer, okay? So I'm going to clear all my drawings. So this is part D, 14, part D. Let's go and see what it says in the mark scheme. So 14, part D. Okay, can you see that there is the first mark and there is the second? Okay, so the line or pen initially moves up. Okay, so that's our consequence, right? And what you've got to do is can you see the downwards acceleration of the ball is much less than the frame? They like that, they want it to be there, but it's in brackets. It doesn't matter if you don't put it. The ball does not move very far in the time it takes for the frame to move down. In other words, the frame goes down and the ball stays where it is. That's what you've got to say. That's your key fact. And then the consequence is that the line or the pen moves up on the paper. It draws a line up on the paper. Can you see that what was something like really vague and woolly? What are we going to say here? Can you see that it turns into key fact, consequence? I mean, in the mark scheme, they're the wrong way round, but it doesn't matter. It doesn't matter. The thing that we thought was a key fact and the thing we thought was the consequence are the 2 points that are on this mark scheme. Okay, now I want you, when you are doing explain questions, I want you please to think of this key fact consequence idea, right? I'm going to clear those drawings right now. I want you to have a go at an explain question. Obviously, it needs to be an appropriate question for your stage of learning. Now, in the last week's lesson, I gave you a table which had got some GCSE questions and some proper A-level questions for year 12 and for year 13. And so what I'm going to do is go back to that first week's lesson, or rather the for week 1 in my course, and I'm going to show you where you can find a table of appropriate questions, and hopefully you'll be able to find an appropriate explain question in there to practice with. Oh, come on. Why are you not loading? Does the ball not move due to inertial tendency? Yeah. Inertia is the reluctance to change motion. Okay. That, I mean, inertia is a word that Newton used a lot, and so he used inertia rather than the name that we give to it now. Inertia is mass. Okay, so inertia is this tendency for an object not to want to change its motion. So if it's stationary, it wants to stay stationary. If it's moving in a straight line, it wants to keep moving in a straight line. And you have to apply a force to get it to change its motion. Is that not Newton's first law? Yes, it is. Yes, it is. Yeah. Okay, so what we're going to do, it's the Ninja Question Analysis Resources. Okay, so you're going to click on there, and you can see there's a spreadsheet that's downloaded. I'm going to open it. And that it's these two. If you are in year 12, you've just started year 12, you want to use these two. The first column is the first paper. Okay, and the second column is the second paper. So that one there is the paper, and the one underneath it, that's the mark scheme. Okay, that is an OCR paper. That's the OCR paper mark scheme. This is rubbish. It's really hard to read, isn't it? Okay, that one there is a paper, and that one there is the mark scheme. I hope you can see my mouse. Okay, so if you are in year 12, you've got two options of papers, and you've got an appropriate paper for your exam board. Okay, so let's go and have a little look at, I'm going to use this one. Oops. Right, so it's control and click. Okay, and again, like before, you can do control F, and I'm going to put in explain. Okay, so here we go. We've got explain. This is a 4-mark explain. Okay, so this is going to be 2 key facts and 2 consequences, probably. But it might be 1 key fact and 3 consequences, and it might be 3 key facts and 1 consequence. But this is, right, this is, it says when the ball hits the ground, energy is transferred from the ball to the earth. Okay, it says explain how the data in figure 1 shows this energy transfer. So you've got to go back and look at figure 1. Okay, there is figure 1. That's a bouncing ball. Okay, how does it show energy is being transferred? Ooh, explain, explain. This is a hard question. Okay, for GCSE, this is a very hard question. Okay, and it's question number 1. Oh my goodness, okay. Okay. Be glad you didn't do your GCSEs in 2018. This is really hard. This is really hard. Okay, so if you're doing AQA, have a go at that explain. I mean, you don't have to. There's 12 explains on that paper. Can you see? So have a go at one, and the first person who says, "Can we go through my answer?" I will let them talk about their explain answer on the thing. Okay, so we're going to do explain, a practice explain. In fact, should we do this one? Should we do this one? This is a 4-mark explain. Okay. Okay, so this is I'm going to do this one because we've not got enough time really. So so this one then is this is the figure that we've got to do, and all I'm going to do is I'm going to do you know what I'm going to do? I'm going to do a duplicate. Is it that one? Yeah, I think it's that one. Right, so I've duplicated that paper. Okay, so that one then put there. And that one can go there. And there we go. And I'm going to go through to the question. It says, explain how the data in figure 1, there is figure 1, shows the energy transfer. Okay. So what data is relevant in figure 1? Can anybody tell me? This is a GCSE question. I can't believe it. It's really hard. Okay. What is the data in figure 1? Okay. This is a bouncing ball. Okay. The gradient of the line shows the acceleration. And that gradient is exactly the same as that gradient. That gradient is 9.81 or 10 at GCSE, right? Which is the acceleration due to gravity. It's little g. That's why it's the same. And that's why it's a straight line, because it's caused by the weight. Remember, weight is mg. That is a special case of F equals ma. I hope you realise that. Okay, so we start off with a 0 velocity and it gets faster and faster and faster until at B something happens. Does anybody know what happens?
The ball hits the ground and changes direction.
Yeah, the ball hits the ground. So this enormous acceleration that's caused, that's indicated by this almost vertical line, right? That is what happens when the ball hits the ground. So basically, somebody has dropped the ball, right? It gets faster and faster and faster until it hits the ground. And then suddenly it hits the ground and it's going in the other direction now. Can you see? They've said that downwards is positive and upwards is negative. Okay, so this is positive. So it accelerates, 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 and then it, bam, it bounces, and then it's going up again. Right, now, what is it about this second triangle that will tell you that it doesn't go up as high as it was originally dropped from? Not the same area, indeed. Right. Okay, so now you've raised your head above the parapet, Saphira. What is it about this graph that tells you, what does the area tell you? I mean, what she's saying is that this area is not the same as this area. Yes, yes, it's distance or displacement. Yes. Okay. In fact, you're right, Danuka, it's displacement. Okay. But yes, you're also right, Saphira, it's the height. Okay. So the pink represents that height and the blue represents that height. Okay, and can you see at D, that's the highest point, it's stopped again. So it's bounced, it's gone up and it's slowing down and it's stopped. Okay, so so can you see right now, if it doesn't bounce back to its original height, what's going on? What's going on? What sort of energy has the ball got to start with? Because the question, explain how the data shows energy transfer. The question's about energy. What sort of energy has the ball got before it's dropped? Good, Charlie. Gravitational potential energy. So up here, remembering this is GCSE, it's mgh, isn't it? That's the energy it's got. That's the potential energy. Right, now, what happens to that potential energy as it falls towards the ground and the velocity whoop, goes up? Well done, Maxwell. Well done, Danica. What happens to that gravitational potential energy as the ball falls down?
Decreases.
Yeah, the gravitational potential energy decreases, but yes, yes, yes! Oh, you're all of you cooking with gas. Yes, it's being converted into kinetic energy, isn't it? In fact, this is that thing, assuming that you can ignore air resistance, all of the gravitational potential energy turns into kinetic energy, and you can use energy to work out what the speed is before it hits the ground. Good, good, good. Okay, so at the top, we've got gravitational potential energy, and at the bottom, we've got kinetic energy. So what happens to it? Because it doesn't bounce up as high as it, right? What can you see that the kinetic energy that we had when it hit the ground isn't all of it returned? Can you see that? Because it doesn't bounce back to its original height, which is given by the area under the graph, that's evidence that some of the energy is lost. What's happening to the energy that's lost when it hits the ground?
Converted to thermal energy.
Thermal energy, sound energy, some is transferred to the surroundings. Yeah, it's thermal energy of the ball or of the ground where it hits. Okay, so absolutely, you're all of you absolutely right. Okay, so now we've got to explain this, right? So how can we explain how the data in figure 1 shows that energy is transferred from the ball to the earth, to the surroundings? Okay, I've drawn all over it, but can you see that's what we've got to do? Can you see the thinking that has to go behind all this? Okay, can you construct an answer to that? Okay, the mark scheme is in that table. I'm going to let you construct an answer for this for your homework, and yeah, and then check to see if you're right. Okay, explain key fact consequence, key fact consequence consequence, or key fact consequence. Maybe it's 4 marks. 1 mark for each key fact, 1 mark for each consequence. Right. Okay. We've not got very long. I've only got 5 more minutes. I haven't got very long, but I want to do something on the other main command word that you are going to come across. And the other main command word that you're going to come across is describe. So explain is key fact consequence. Describe is say what you see. But it's not just say what you see, it's say everything that you see. And the really important thing to remember is everything in physics includes numbers. So if, for example, you have a graph, force, extension, and it's a straight line through the origin, and you are asked to describe the relationship between force and extension, you have got to say that force is directly proportional to the extension. That means a straight line through the origin. Or you could say F is equal to Kx, right? Which is the same thing. K is just a constant. So, and you'd only get 1 mark out of 2 because you haven't completely described it. You haven't given any numbers. So you'd have to give them people a point on the graph, or you'd have to say the gradient is this, or the value for K in your equation is this. So describe is not just say what you see or what you would see with your mind's eye. If you can't actually see electrons moving up and down energy levels in atoms, for example, it's what you would see if you could see them. Right, but so you're describing things, you're saying what you see or what you would see, okay, but that's not enough. You've got to say everything. So if there is numbers, you've got to describe the numbers as well, okay. And this is the biggest thing that people get wrong with describe questions. When they're asked to describe, they don't describe, they explain. And behold, I mean, you know, lo and behold, when you explain a describe question, you don't get any marks because what you've said is not on the mark scheme. So, and this is a really, really important point, okay? This is something that lots and lots of students never get their head around, okay? You shouldn't really think of your question paper, your exam paper, as a question paper. I mean, it is obviously because they're asking you questions. But what I want you to think of it as, I want you to think of it as instructions on what to write. And you've got to follow the instructions. So if they tell you to describe something, you describe it, you say what you see. And if they tell you to explain something, then you explain it. Key fact, consequence. Don't describe when you've been asked to explain, and don't explain when you've been asked to describe. And then, of course, there's some questions where you have to describe and explain, in which case you must do both. Okay? Okay, right now, it's really, really simple to say these things, and it's much harder to remember these rules about how you've got to structure your answer when you're faced with an A-level question. So what I want you to do is I want you to have a bit of a practice. Okay, so find some suitable questions, especially explain, especially describe, and I want you to have a go at answering them. Okay, and I want each of you to submit to me, just send it on WhatsApp, submit to me your answer. You can just take a picture of it, okay? So it could be on a screen or it could be on a piece of paper, don't mind. Take a picture and submit to me your answer for a describe or, well, preferably an explain question of the sort that's suitable for your level of learning. So for the new year 12s, maybe a difficult GCSE question, and for the year 13s, an AS paper question. Okay, one describe and one explain, and submit them to me, please. Okay, describe is say what you see, everything that you would see. Okay.